given y plus x is greater than 2 and y is less than or equal to 3x minus 2, which graph shows the solution of the given set of inequalities? Okay, so this problem is asking for us to identify which graph represents the solution of this set of inequalities. So we have two inequalities here, and when we're talking about the solution of a set of inequalities, this is really solving a system of inequalities. So that's the type of problem this is. So in order to solve a system, we need to graph each of the two inequalities on the same graph paper and find where the two inequalities overlap. And so the easiest way to do that is turn to the back of your Regents book and open up or rip off the scrap paper, because this is where this comes in really handy. So what we can do first is draw some grids. If you have a ruler, it's helpful, but we'll just pretend that we don't, and we'll draw an X and Y axis on our scrap paper. And I'll do the best I can. Yeah, it's good enough. Here's our X-axis, here's our Y-axis. It's always nice to add our arrows, even though this is just scrap. Keep the good habits. Okay, so here's our X and our Y. Now we need to graph each of these inequalities. So the first inequality, Y plus X is greater than 2. Well, the easiest way to graph this inequality is to get it into similar to y slope-intercept form, where for a line it's y equals mx plus b. But similarly for an inequality, it would be y is greater than or less than or equal to mx plus b, where m is the slope and b is the y-intercept. So whenever we isolate y, it allows us to graph this much easier. So if we look at our first inequality, y plus x is greater than 2, y is not by itself, but we can get it by itself pretty quickly. So the way we can do that is y plus x is greater than 2. And to get y by itself, we can subtract x from both sides of the inequality. And when we do that, we have plus x and a negative x becomes 0, and we're left with just y on the left side of the inequality, and is greater than, and then 2 minus x. And I'm looking here. We have the 2, the constant first, the 2, and then the minus x. And, and this is fine. If you're comfortable with this, that's fine. But I like to put the x first. So I'm going to write y is greater than, and I'm going to pull the x out front. But remember the negative, the sign in front of the value, either a variable or a constant, always travels with it when we rearrange. So the negative x or the minus x, we pull that first. We have negative x. And then the 2 is positive, so we have the plus 2. Okay, so we're going to graph this inequality here. And I'll do this one in pink. So we know that the y-intercept is positive 2. So we'll go up to 2 and put our point. And the slope of this, what we think of as the boundary line, will be negative 1 or negative 1x. So when we have a slope of negative 1, we can think of that as negative 1 over 1. So the change in y is negative 1, and the change in x, rise over run, is positive 1. So when the change in y is negative, we are actually going down by 1. And when the change in x is positive, we're going to the right. So we're going down and to the right, and we'll plot a second point. And we're going down and to the right, and we'll plot a second point. And we can keep doing this to help us find our boundary line. And we'll go in both directions. Remember, if we're going down and right, it's the same as going up and left. And if you've forgotten why that is, remember negative 1 over 1 is the same as 1 over negative 1. This is the same. These are two different ways to write negative 1. So here we go. Here are some points along our boundary line. Now, if you recall, when we're dealing with inequalities, if this were an equation, we could just draw our line to represent all points on that line, all solutions to that equation. But we're dealing with an inequality, so we have to be careful when we just go to automatically connect our lines. Remember, when we have greater than, or if we have less than, without the equal sign, then what that means is the points that would be sitting on that line are not part of the solution of this inequality. So when we think, well, if we're not including the points on the line, then we can't actually draw a solid line like we're used to. So what we actually do is we draw a dotted line or a dashed line to represent that this boundary line is not, the points on this boundary line are not included in the solution set of this single inequality. So we'll just graph little dashes here. Like this. Just as long as it's not solid, you'll be okay. It can be points, it can be dashes, doesn't really matter. And don't forget to put the arrows, because this boundary line goes forever in all directions. And we are going to label our inequality. So we could either label it using this form, or we can label it using the original form. It doesn't matter because they are equivalent. So out of habit, I always like to use the original one that's given. So y plus x is greater than 2. I'm just going to write that next to the line. Y plus x is greater than 2. And you might be thinking, well, why are you doing this so carefully? Because this is just scrap paper. I know. It's a multiple choice question. But, it's, again, keeping the good habits good. Okay, so then we've now graphed the boundary line, and we have to go and graph the solution set. So when we do that, we have to think, well, we know that since this is an inequality, we're not just including points on a boundary line or not on a boundary line, but points elsewhere. So the easiest way to do this is to determine which way we are including. So we have to determine if either all the points above the boundary line up in this region, or all the points below the boundary line down in this region represent the solution set of this inequality. And so you can just pick a test point. The easiest test point to pick is 0, 0. Unless, of course, the boundary line goes right through 0, 0, then you have to pick another test point. So we'll test 0, 0. So what we're going to do is we're going to plug 0 in for y and 0 in for x. So let's plug 0 in for y is greater than negative 0, which is 0, same thing, plus 2. So 0 plus 2 is 2. 0 is greater than 2. So is 0 greater than 2? We ask that question, and the answer is no. This is false. This does not work. So because 0 is this idea here, this inequality here is not true. It is a false statement. 0 is greater than 2 is false. We can say then that 0, 0 is not part of the solution set of this inequality. And since we're dealing with either all the points down here or all the points up here, and we know this point isn't included, then we can say that it's not this set of points, but rather the set of points up on top. So it's really the solution set includes all the points up in here, every single point. And sometimes, you're like, well, do I have to plot all the points? No. A lot of times we represent this just by using these hashes. And this is not sophisticated. This is simply meant to represent all points up here. You might have learned this as the concept of shading. Even though artistically you're shading, what you're really doing is representing the idea that every single point up in this area, down to the little points in between, are all solutions to this inequality. So, right away you might be able to eliminate a few answer choices. You could say, well, answer choice 3 here, it looks to me like there's the boundary line. So I'm just going to draw that. That one matches that one. And up here, the shading is above. Well, if I look here, I see this part is not shaded, but rather this was shaded below. So at this point, you could eliminate this answer choice here if you'd like. You could also eliminate this answer choice because the shading is also below. You actually could have eliminated this answer choice as well because you know that the boundary line is here, it's solid, but here it was dashed. So we know that we needed a dashed boundary line, and so this one was not correct. Either way, this is wrong in both counts. So 3 and 4 are not correct. So then it's down to 1 and 2. And in order to figure out which of these is the correct answer, we need to graph the other inequality. And so we have y is less than or equal to 3x minus 2. Well, if I compare the form of this inequality with y equals mx plus b, I already can see that y is already by itself on the left side of the inequality. So this one's already ready to graph as is. That's nice. So I'm going to graph this one in purple. So we have the y-intercept, in this case is -2. So we're going to start down on our y-axis, we'll start down at -2. And the slope is +3. So m, the slope of this inequality, or the boundary line of this inequality is +3, or +3/1. So the change in y over the change in x, sometimes considered rise over run. So we are rising or changing, the rate of change here is 3/1. So we go up from this -2, we go up 3, 1, 2, and 3, and we run 1, or to the right 1. 1, 2, 3, 1. 1, 2, 3, and right 1. 1, 2, 3, and right 1. 1, 2, 3. And you can go on for as long as you want. And then this, remember, up 3 and right 1, similarly is the same as down 3 and left 1, because I have to make a straight line here. Down 3 and left 1, down 3 and left 1. You can go on forever if you want, or I'll just stop at the end of my grid. Okay, so now we have some points along the boundary line. And now we have to look at the inequality symbol. Well, I noticed that this is a less than, but it also has the equal sign, less than or equal to. So as soon as you see that equals piece, we know that this is going to be a solid boundary line, which means that the points, every single point along this line, not just the points we graph, but all the points in between, which make up that line, are part of the solution set. So this one has a solid boundary line. Those points are included in the solution set of this inequality. And we'll put our arrows here for good measure. And let's go ahead and label it for good measure. So y is less than, I'm using the original one, which we didn't change, 3x minus 2. Okay, now again, this question of which way do we shade? And this is going to give us, the answer. Well, you're probably thinking, hey, go ahead and just stop, because I can see that answer choice number 1 cannot be right because this guy has a dashed line. So you could probably say, all right, answer choice 1, answer choice 2 is correct. And that would be correct. So we can actually stop there because we've eliminated this one. But I want to give this one a thorough look. So just as a review of which way we shade, again, we're looking up above. We're considering all the points above the purple boundary line as either the solution set of that inequality, or we're looking at all the points below it. And so we have to decide. And again, we'll use the test point. I'll use green here, 0, 0, because if you notice 0, 0 is not on the boundary line, so it's a good one to use. So we're going to plug 0 in for y, 0 in for x, and we plug 0 in for y, we get 0 is less than or equal to, 3 times 0 is 0, and a minus 2. 0 minus 2 is negative 2, so we have this inequality, 0 is less than negative 2. And so we have to consider that. Is that true? Is 0 less than or equal to negative 2? It's definitely not equal to negative 2, but is it less than negative 2? Well, no. 0 is not less than negative 2. Negative 2 is less than 0. And if you've forgotten, graph a number line real quick. Here's 0, here's a positive 1 and positive 2. Here's negative 1 and here's negative 2. If you think about which one's less, well, the one to the left is less. And negative 2 is to the left of 0. So negative 2 is less than 0, not the other way around. 0 is not less than negative 2. So similarly, this is not true. And so 0, 0 is not a solution to this inequality either, or to this inequality. And so what that means is 0, 0 is not included, which means we need to shade the other side that doesn't include 0, 0. And I'll do that one in orange. And so again, we could sit here all day and plot every single point, or as close to it as we can in one day, or we can just use the shortcut and just use our shading, this idea of shading here, or representing all points. Okay, so the orange represents the solution set of this inequality, and the pink represents the solution set of this inequality. And when we're talking about the solution of the set of inequalities or a system of inequalities, we have to consider where the two regions overlap. So we basically have to look for where there's orange and pink at the same time, and that's here. If you notice up in this section here, this represents the solution set of our set of inequalities. So this guy here is our solution set. So all the points up here satisfy both inequalities at the same time. and sometimes you'll see a big S here. But we don't in this case. And sure enough, this answer matches answer choice 2, which we already found out earlier by process of elimination. But now that's the complete explanation, and the answer to this problem is 2.